All right, so this is transformations lesson 3. It's reflections, and we'll show you how these work pretty quickly here. To start off with, you can think about this negative f at x as being this negative x squared minus 10x plus 25, and then distribute it through. But we don't actually need to do that. We could just go y1 is all of that stuff, and y2 equals negative y1 at x. And then that will work out for those pieces. I'm just going to show you what that would look like in here. So y1 is x squared minus 10x plus 25. And then down here, I'm going to go just negative vars y vars function y1 at x, close bracket. There we go. So there's my original. And then there is my image file. So it's a reflection vertically. Same vertex, same invariant point. So the coordinates of the invariant point are at 5, 0, not 0, 5. Try that again. Same thing here. I'm not going to bother doing this in your graphing calculator. Again, same thing. Just go negative y1. Actually, I guess I'll show it for this one. I'm just going to go back into here, and now I can just change this. Make this x cubed minus 8. And then just delete the rest of that. There's my first graph. There's my second graph. So again, vertical reflection. And with this one, it's going to do the same thing. Vertical reflection, and the invariant points are always right there on the x-axis. The x-intercepts are there. And the reason is that this is a y-value replacement. We want to imagine moving that negative back over here. So y-value replace it, so we've replaced y with negative y. So if the y-intercept was 8, it's now negative 8. Same thing here, except now instead of negative y1 at x, it's just going to be y1 at negative x. So I'll show you the first one here on my calculator, and then I will just trust that you can do the rest of these yourself. So this is x squared minus 10x plus 25. Get my graph, there's my original, there's my image. So in this case, it's the x that's flopped over. So instead of having a vertex at positive 5, we now have a vertex at negative 5. The invariant point, well, we can't see it very well, but way up here at 25, 0, there's going to be an invariant point. With this one, all the x coordinates are going to flip, so it's going to look something like that. I didn't draw that all that accurately, but it works. So here it's at negative 8, 0. I guess I should actually write that invariant point up here. So this would be 0, 25. So it's always the y-intercept, anyway. And actually, I'll show you this algebraically. This would be f at empty bracket equals empty bracket squared minus 10 empty bracket plus 25. And in my empty bracket, put negative x. So in this case, this is going to be x squared still. Negative x squared is still just x squared. But negative 10 times negative x is going to become positive 10x plus 25. This is going to be negative x cubed minus 8. Not that we really care. And then this one's going to do this. So this we call a horizontal reflection. The last one is this inverse activity. And remember, with inverses, what ends up happening is that all of your coordinates flip. So if the coordinate was 5, 0, it becomes 0, 5. We can also do this algebraically by replacing the variables. So I write x equals y minus 5 squared. All of your x's and y's flip. Now, my graphing calculator can't do this very well, but Desmos can. So what we're going to do is draw that out. If you were solving for y, you'd first have to take the square root of both sides. So you get root x equals y minus 5, although it's technically plus or minus root x. So we're going to get y equals root x plus 5 and y equals negative root x plus 5. But in Desmos, we can actually just type those whole things in. So y equals x minus 5 all squared. Or I could write x equals y minus 5 all squared. That's how that lines up. Now, there's invariant points that are true invariant points, and then there's invariant points that actually aren't. So like these two are not actually invariant points because the values actually moved. This one that was 2.4, 6.5 became 6.5, 2.4. It just so happened another one moved back to the same place. This one that's 3.0209, 3.209 actually stayed exactly where it was. It's truly invariant. Does that make sense? Okay. So that's what they want us to show on here. And again, if I was graphing this on a TI-84, TI-83, you'd have to do the 2 square root graphs. So I'm going to clear that out. And I'm going to go square root of x plus, close my bracket there, plus 5, and square root of x minus, negative square root plus 5. So there's my original, there's my inverse. Now there's actually another really good way of doing this. Here I actually had to put this into 2 places because the inverse isn't a function. But we'll talk more about that later. But you could also go to here and under draw. So you go second program draw. Now down this list here, number 8 is draw inverse. You tell it what to draw the inverse of, which is vars, y vars, function y1. And there it'll draw it. Now this in the drawings, it's not a true graph. It's not a live graph penciled in. So it doesn't work quite as nicely. You can't find intersections with things. So that's how that all works out. So this is going to look like this. And the 2 invariant points are these true invariant points that didn't actually move. Now, if I was to inverse this thing, the point 0, negative 8 is going to be negative 8, 0. This point that is 1, negative 7 is going to be negative 7, 1. So it's going to kind of look like this. Again, I'm going to do that without writing the equation out. Well, I'll do it here. X equals y cubed minus 8. Y cubed equals x plus 8, so y equals cube root x plus 8. we talk about these as being reflections. And in this case, the reflections about the line y equals x. If we imagine this line on here, you can see that everything is an image of itself on the other side of that line. A little bit like Alice in Wonderland through the looking glass. All right, back to here. If this one got reflected, it's going to go this way. Instead of the point at -1, 2, it's going to be 2, -1. And so it's going to come like that. Now, in the replacement y's, we replace y with x and x with y. And that's the replacement that happened. So here we go. This is just some notes. This is a graph reflected in the x-axis, and it's a graph of negative f at x. This we also call vertical reflection. This would be a horizontal reflection. And it's reflected in the y-axis. And this would be f at negative x. It's again, think about what gets replaced. This is reflection in this or inverse. And the line is y equals x and is the graph of x equals f at y. Or technically, you can even do f inverse of x. That notation is also, whatever. I'm going to pull these, skip it. Undo, 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 undo. Undo, 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 undo. Undo, undo. Okay, I'll just leave that as now. So this is either x equals f at y or f -1 of x, inverse function of x. Again, that just kind of is notes on those same pieces. So if I got this graph, sketch negative f at x, well, that's going to be a vertical reflect. So this is going to look like down to here. Like that. This is going to be a horizontal reflect, so it's going to look like this. Oh, get down to there. And then on this other side, it's going to keep going down to 4. And then down to -3. And then back up. Something like that. I'm actually going to try a red color. Maybe that might stand out better against this black on black. But this is where we do the inverse. So what I'm going to do here is just switch the coordinates. Instead of -5, 0, 0, -5, -4, 6 is going to be 6, -4. -2, 6 is going to be 6, -2. So that's how all of those pieces line up. This piece here is going to go from all the way down to 7, -3, but instead that'll be -3, 7. So that's where that whole piece is going to go. I didn't draw it all that well, but you get the idea. And then back up here to 9, 0. In these cases, you just say what happened. So this is inverse, or reflection along the line y equals x. This is horizontal reflect, which is y equals f at -x. And this is negative f at x, which is also a vertical reflection. Okay. Now we can also combine reflections. this gets a little goofy, and actually I would suggest it's probably a little bit beyond the scope of the course. So I'm not going to deal with it right now. I might come back and make another video later. But I will certainly not test you on it. And yeah. And I think I've never seen it on the diploma. So I'm just going to call that a day for right now for lesson 3.